Hello, my name is Brian Toe, and this is my report on Lab 4 oscillations. Within the lab, we observed a mass as it swings in an arc while oscillating on a spring. We observed this mass to create a Glowscript model that follows this motion and measures the changes in energy that occur. In terms of trends in energy, the potential and kinetic energies were opposite one another. As such, total energy was zero because it was the sum of both potential and kinetic energy, which canceled out to yield zero. Newton's second law is involved as it states the change in momentum is equal to the force times the change in time, which allows us to break down net force into the sum of spring force and gravity, and breaking down net force even further into its components as shown below. The energy principle is involved as the model involved a system of the mass, the spring, and earth. The change in energy was equal to zero because there is no work or change in energy. The formulas for kinetic energy, spring energy, and gravitational energy are shown as so, and are used to calculate these different energies and use them within the Glowscript model. In terms of observational data, we had an initial mass of 0.402 kilograms, initial position of negative 0.113 x, negative 0.629 y, and 0 z meters. The initial velocity was 0 meters per second, and the oscillation time was calculated to be 1.52 seconds per oscillation, using the final time of the oscillation minus the initial time of the oscillations, divided by how many oscillations there are, which is 2. We use this mass to calculate the gravitational force as shown to be negative 3.9396 newtons. The oscillation time was used to calculate the spring constant using this formula and reorganizing that formula to solve for the spring constant, and to be 6.83 newtons per meter. The spring constant and the length of the spring stretched was used to find the length of the spring at rest using the following reorganized formula, and the length of the spring at rest was 0.123 meters. And all of these different measurements were used within the Glowscript model and inputted in places such as shown, which line 48 and beyond. And here is for the initial conditions and measurements of the system. And then later on in the model, different measurements of the spring and different energies are computed as shown, as well as inputted. And then even further down is updating different values about the spring, as well as calculating different changes in energy as shown. And when run, the Glowscript model yielded these results when the initial observational data of tracker was inputted. And in terms of the what does it mean questions, the energy principle is satisfied because the energy of the system is equal to the energy of the surroundings, as shown by the delta E being 0, because the energy of the surroundings did not interact at all, or the surroundings did not really interact with the system, and so it's just no work is being done on the system. And in terms of the oscillation period of x versus y, if the x oscillation period was 1.585 and the y oscillation period was 1.52, and these discrepancies could have changed the spring constant, but y was used because it's in the same axis as the spring. Potential sources for error are not accounting for the drag force in the model and inaccurate point placement in tracker, which could yield inaccurate observation data being fed into the model.